All right, this is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. All right, so let's go ahead and get started. It's a good day, so let's figure out what is a positive way that you have changed as you have gotten older, right? So maybe you've gotten more patient, maybe you've gotten more active, maybe you've been calmer, or it's less easy to get you angry, maybe you're more outgoing. Go ahead, tell me on the whiteboard, what is one positive way that you have improved as you've gotten older? Obviously, all of our participation we've been working with so far, we've been trying to figure out how we can continue to improve, but the reality is you've probably improved in many areas already. Yeah, exactly, Ireland, right? You've gotten more knowledgeable as you've been learning more. Appreciating yourself more. Oh, I love these. Go ahead, get your answers up there. I do see Efren and Taylor on the board. Ireland's in the chat box. Let's get a few more people participating. Tell me a positive way that you have improved as you've gotten older, as that you've changed. Looking like I got arrow on the board. Chat box here. Let's go ahead. Amanda, Amir, Tony, want to hear from you on the whiteboard. Let's see here. Bradley and Chanel, want to hear from you as well. Ethan and Jade and Jasmine, go ahead, participate up on the board. You've gotten taller. I guess that's a positive thing as long as you want to be tall, right? Awesome. Noah's on the board. Let's get Jess and Jody on the board. Matt, want to hear from Orlando and Parker. I see Dree on the board. Awesome. And let's hear from TJ. I see Valeska typing. And let's get Yolese on the board. Go ahead, tell me a way that you have improved, positive way you've changed as you've gotten older. Love it. Remember, those links are in the chat box. They're popping up every few moments with the password underneath them. So make sure you are opening up your ticket, giving me a green check while we're working on this. All right, let's go ahead. I'm going to start going over these answers. You can keep on typing them up here, but I want to make sure that we're not wasting time here. What is it? Most men stop growing around 21 in terms of height. I think most women stop growing around 18 in terms of height. Yeah, looking good. All right, so Ireland, you're still short. I am also very short. I am 5'2". So let's see here. You've gotten more mature, Caleb. Yes. Yeah, I mean, I think it's with all of us being different. Biology doesn't affect us all the same. Oh, she's 14 and she's almost 6 foot. Oh my gosh. It's possible, Efren. It might just be an inch, right? You've gotten more patient, Valeska. That's awesome. All right, so let's see here. You've gotten more active, but as you get older, Efren, you'll probably get lazier. So that's probably something that habit-wise you want to make sure you are starting to instill good habits now. That way that doesn't happen. Arrow, you've become more intuitive, right? So maybe better able to understand situations and other people, making decisions, being more mature in general, right? Maturity has a lot of different attributes to it. So if you're able to look back and say a lot of my things in life have improved, right? You've become more mature. Ireland, so Ireland, you're short, but your sister is almost 6 foot, and she's funny how those genetics work. Noah, you said you've got to know who you really are and what you really like, right? You get to know yourself better. Absolutely. Oh, you're adopted. I'm also adopted. Yeah, my entire family is not super tall though. My dad is 5'7", my mom's 5'8", and my brother's like 5'8" as well. So we're all, but I'm definitely the tiniest. Oh, you're from Russia. Cool. Yeah, my parents are one's Italian, one's so. Girls like being tall, but yeah, I mean, I think people need to just learn to appreciate each other regardless of how they look, right? Dree, you said you've become a lot more responsible. Absolutely, right? You've been able to take care of yourself more. Hopefully, as we get older and older, we should become more responsible. That's a natural progression in life. You appreciate yourself more, Taylor. That is amazing, right? Sometimes it's hard to appreciate ourselves when we're younger. And you've become more kind to your siblings, Bradley. That's an amazing thing in life, right? I feel like my brother and I were always kind of at each other's necks for our childhoods, but as we got older, we developed some really good relationships that I'm very happy with now. Awesome. So again, we're working on making good habits. We're working on improving ourselves. So yeah, so it's a good thing to think about, right? Where have we been? look at how much we've improved already, and that can inform us and remind us that we can still continue to improve as we get older and move out of high school and so on and so forth. Smiley faces if you feel good about that, if this is making sense to you. Just want to encourage you. You've come a long way, and then you can still keep on moving, still keep on improving. Love it. All right, everyone. Cool. So you should be in your May 1st attendance ticket. Mr. Alch just put those links in the chat box for us again. And the password is right there for you too. So please go ahead, open that up. Give me a green check if you're able to get it open. Dorian, you're 6 foot. Your sister's half your height at 10 years old. They grow fast. I know, right? Yeah, my daughter, she's currently like 33 inches. So they say that at a year and a half, if you double the height for females, that's generally how tall they'll end up being. So she'll probably end up being 5. So definitely a little bit taller than me, but not quite as tall as my husband. He's 6'2". Yeah, you are very tall, Dorian. All right, I do see lots of green checks. Again, let me know if you're having trouble opening those. All right, looking good. Perfect. Okay, so we are on this should say day 14. We're on day 14 out of 45. And today we are starting unit number 4. We're going to be introducing you to atoms. I have some really quick announcements. Yes. All right, cool, guys. Okay, let's go ahead and refocus in the chat box because I want to make sure that we are ready to go with our content for today. But some quick announcements. I do want to let you guys know because I know many of you are working on fitness or health goals, not just school goals, but there is Planet Fitness is having what's called the Teen Summer Challenge, and so you can actually go to Planet Fitness as long as your age is 15 to 18. So sorry, 14-year-olds. But let's go ahead. I'm gonna send this link to you really quick. So Planet Fitness Challenge. All right. So, Efren, I'm just saying that Planet Fitness has this really cool program that they run where you can actually go to Planet Fitness. It's a gym. Yeah, Planet Fitness is definitely great. It's no frills. It's simple. It gets stuff done, right? So if you go to that website that I just sent you, this planetfitness.com/Teen Summer Challenge, they have all the information there. You can just go to a gym and sign up, and it's starting in 14 days. So definitely get there, get some free gym time in. And work more towards those health goals that you guys have. Awesome. Okay. Yeah. So that being said, my other announcement is that we are moving today's support sessions, the 2 o'clock and 2:31, to Friday. I do have a doctor's appointment around that time to check on my sprained ankle. So I want to make sure that I'm respecting your time, and I don't want to feel like I'm rushing you or that I'm being rushed. So just letting you know, we're moving those days to Friday. So remember, support sessions, you can get some extra credit during them. So you can come tomorrow morning or Friday afternoon. Thumbs up if that makes sense. Love it. Okay, cool. Yeah, I really enjoy working out too. It's lots of fun. I think you enjoy it more and more once you actually get into the rhythm or habit of it, right? Cool. All right, so this unit, we are talking all about atoms. So we're going to take a look at what the atom is, its characteristics. We're going to talk about some really important details about the atom, including what the different atomic models are, what atomic number, mass, and the nucleus of an atom is. And we're also going to talk a little bit about radioactivity. So radioactive dating, fusion, and fission. So lots of great stuff in this unit. And this is going to actually lay the basis for the rest of our quarter because we're talking about chemistry this quarter. So lots and lots of detail about atoms, elements, so on and so forth. Yeah, I am feeling a lot better. It's still a little bit surgery, but it's definitely healing. Thanks. All right. So today, pretty easy. We should be able to explain the different components of the atoms, and then we should be able to identify the different types of atomic models that we've had throughout history. Dorian, I haven't gotten a chance to see Endgame, so again, no spoilers. I don't really go to the movies very often anymore because it's difficult with my daughter. So I'll probably just wait until it comes out on Amazon and then buy it from Amazon. So you can't do spoilers for quite some time, that means. Looking good. All right, so atoms are composed of a couple different things. All right, so we're starting. Refocus in the chat box. Thank you. All right, so the nucleus in the center is composed of protons and neutrons, and then electrons are floating around the nucleus, and those have a negative charge. So let's jump into it. Let's look at this. Now, remember, we need to review some definitions. Remember, at first unit, we talked about matter is all the stuff around you. Tell me, what are some things around you that are made up of matter? So anything that has mass, right? Think about the things around you, or what things around you are made of mass, are made of matter, or have mass and are made of matter. Yeah, your laptop, your pen, what else? Your dog, right? Yourself, a cup. Absolutely, yes, you, exactly, Efren. Your chair, a magazine. What about things that you can't necessarily see but still have mass? What's something that you can't necessarily see? Yeah, air. So even air is a type of matter made of mass, okay? Now, that being said, these are made up of tiny little building blocks called atoms. We can't see atoms, they're too tiny, but if we were to zoom in on an atomic level, they would be the smallest single unit of matter that still keeps its identity, right? So this is important to understand. Like, there are things that are smaller than atoms, even teeny tinier, but those things that are smaller would change the identity of that matter. Give me a smiley face if that makes sense. So the smallest building block would actually be the atom. So if you imagine matter is in the house, the atom is the single brick, okay? Now, if you take a bunch of the same atoms and put them together, that's just what we call an element, okay? So, but it has to be the same atom. So it has to be like thousands of gold atoms would be the element gold, or thousands, millions of silver atoms would be the element silver, okay? So matter is the house, an atom is a single brick, and the element is the wall made up of the same types of bricks. Okay, one more time, give me a thumbs up from your smiley face menu if you understand that. Okay, this should all be review. Hopefully this is making sense. Perfect. Okay, love it. So let's go ahead and match these up. Let's make sure we understand. Please use thin lines. Please use any color but red. Match these up on the board. Again, this is all review, so hopefully we should be paper nap. All right. Oh, looks like we have lots of agreement. Let's make sure that we are all agreeing on the correct things. I'm going to pause really quick and get ready. This will be number 1 in your ticket for today. So let's take a look. Atoms here are a single building block of matter. Exactly, right there, the single brick. Matter is everything in the universe that has mass, right? Imagine that's the house or the building. It's the big picture. And then the element is a substance made up of many of the same type of atom, right? So it's a wall made up of all the same types of bricks, okay? So this is number 1 in your ticket. Give me a green check when you have it saved. You have 30 seconds to get this done. Go, go, go. Green checks all around. Bradley, Jess, the 4th box in your participants panel. Hover over it and choose green check. Yeah, so my dad is Italian. That's why my last name is Fiorello. Fiorello means little flower in Italian. Yeah, I have been to the Griffith Observatory. I'll try to remember to put some pictures up next week of my family at Griffith. Oh, cool, Taylor. Awesome. Yeah, I know a little bit of Italian too, so definitely a big part of my cultural background. Looking good. All right, everyone. So I have a quick joke for you. Never trust an atom. They make up everything. Go ahead, give me a smiley face or an LOL once you. All right, so literally they do make up everything, right? But physically, not in terms of lying, but you know, it's a pun. All right, so let me go ahead. I'm going to go ahead and share this with you. We're going to go ahead and do a little bit of analysis of what an atom, the different parts of an atom, and what it looks like. All right, take a look at this, everyone. So give me a thumbs up if you can see my screen here. All right, perfect. All right, guys, so what we're going to do is atoms are made up of 3 different parts, okay? And you can see these 3 parts down here, protons, neutrons, and electrons. We're going to go ahead and figure out some important characteristics based on what we see happen when I add these different parts to this atom, okay? So first I'm going to go ahead and drop a proton in. Where do you notice the proton goes when I drop it in? Tell me in the chat box, where do the protons go when I drop them in? What do you see happening? Which part of the atom are they going? Yeah, they're going to the very center, exactly. So they're going to the very center. That's important to understand. Protons are in the center of the atom. And now what do you notice is happening to the identity of our element as we add more and more protons? What do you notice is happening? Yeah, so they are building up, but what I want you to notice is specifically what's happening to this name. Yeah, the name changes. So this is really important to understand that protons are in charge of the identity of the element. So if you change the number of protons, you would be changing the type of atom, right? So this is carbon. If it has another proton, it becomes nitrogen. If it has another proton, it becomes oxygen. Smiley faces if that makes sense. Protons are in the center and they are in charge of the identity of the element. Excellent. Another thing that I want you to notice is currently what is our net charge? What is our net charge? Take a look at what you see here. Yeah, it says we have a positive 8 net charge. And since we have 8 protons, that tells you that each proton itself is worth how much charge? Okay, so we have positive 8 charge overall. There's 8 protons. Yeah, that means that each proton has a positive 1 charge. So I'm going to write this in the center. So protons are in the chat box. Protons are in the center, right? They're in charge of identity, and they have a positive +1 charge. Thumbs up if that makes sense so far. Thumbs up if that makes sense so far. Okay, so we've got some good information about protons. Good information about protons. Now, what I want you to notice now, okay, is I forgot to put this up. You'll notice that this is not a stable atom. Okay, it's currently unstable. So what I'm going to go ahead and do, I'm going to try adding my other particle, neutrons, and see what happens. Right, so let's add some particles here. Where do you notice these neutrons are going? Where are these neutrons going when I'm adding them to the atom? Yeah, those are actually also going in the center. They're also going in the center. Awesome. Now, it's now stable, right? So what does that tell you neutrons help with? What does that tell you that neutrons help with? Okay, now that our atom is stable after we've added a bunch of neutrons, what role do neutrons have? Yeah, it's not necessarily that they're neutralizing, but they are a stabilization, right? So they do help stabilize our nucleus, or the center of our atom. So neutrons are in the center, right? So they're in the center, they help stabilize. And another thing I want you to notice is that as I'm taking or adding away neutrons, what do you notice is happening to the mass or the weight of the atom, right? We'll talk a little bit later about how mass and weight are a little bit different, but for now you can think of them very similarly. What's happening to our mass number? Yeah, so it changes, right? So neutrons also they contribute to mass, which you'll actually notice I forgot to mention, protons also contribute to mass, right? So I can actually take away protons and you would see the mass change there too. So protons also contribute to mass. Okay, awesome. All right, so we've got that. We've got some stable carbon. The center of the carbon is stable. Now let's go ahead and add some electrons. So take a look at our screen, and I want you to notice what begins changing on the screen as I add electrons. What do you notice? There's something as I add electrons. Yeah, the net charge is changing, right? You'll notice the net charge is actually going down, right? So we had a bunch of positive charges from our protons, but now that's actually decreasing, and that tells you electrons have what kind of charge? What kind of charge do electrons have if they're able to cancel out positive charges? Yeah, electrons have the opposite charge. So when I add an equal amount of electrons, it actually cancels out our charge because these negatives cancel out the positives from the protons. Smiley faces if that's beginning to make sense. Smiley faces if that's beginning to make sense. One other thing I want you to notice is where are the electrons? Okay, where are the electrons going? So they're negative, right? Where are they going? Are they in the center or are they outside? Are they in the center or are they outside? Yeah, they go on the outside, exactly. So we'll notice that electrons are actually hanging out outside on these rings of the atom. And one other thing I want you to notice is that when I take away or add atoms, does it change the mass? When I take away or add electrons, does it change our mass? Take a look here. Is our mass changing at all? No, so this is also really important. So electrons have a -1 charge, they're on the outside, and they do not have mass. They're not changing the mass or the weight of the atom. All right, go ahead, give me a thumbs up or a smiley face or an LOL, everyone, if that's beginning to make sense. All right, so you actually just learned a lot about the atom, and now we're going to go ahead and actually break that down. Okay, so you definitely analyzed it very, very well. So let's go ahead and synthesize all that information. So protons have a positive charge. Hold on, guys. Sorry, one second. Here we go. Protons have a positive charge. What I want you to think about is when you think about the word pro, like pros or cons, what do you think of when you think of pro? What do you think of when you think of pros and cons? Tell me in the chat box. What does the pro part mean? Yeah, the pro part means like the good, right? So that's how I remember that protons are positive because pros in general are good things. Pros and cons, the pros are the good things. So that should help you remember protons have a positive charge. They also both start with P. All right, so that's helpful. Protons, positive protons. Okay, now that being said, Again, they are in charge of the identity of the atom. Whenever we change the protons, the actual identity of the atom totally changed, right? It went from carbon to oxygen, which are two totally different elements or atoms. We also call this in science the atomic number. So the atomic number is the atom's identity. It's the number of protons. And you'll notice, remember, they have mass. So the units for mass with atoms are atomic mass units, AMUs. And so it weighs 1 AMU. Every time we added a proton, it added to the mass of the atom overall. Okay? Now, neutrons, all right, you'll notice neutrons, the first 5 letters here look like the word what? The first 5 letters here, neutrons, look like an arrow. What word does that look like? I see Jade typing. I see Noah typing. Yeah, exactly. It looks literally like the word neutral. So neutrons and neutral both start with the first same 5 letters. So that should help you remember. Neutrons have a neutral charge. What's another, what number would go with a neutral charge? Right? So positive charge would be +1. What would a neutral charge? What number could I label that as? Yeah, exactly. I would label that as 0, right? So positive charge is +1. Neutral charge is just 0. Smiley faces if that makes sense. So it has 0 charge or a neutral charge. Okay. Now, the role of neutrons is they help to stabilize the nucleus, right, the center. So they prevent protons from repelling from each other, which would be very unstable. So neutrons, because of their neutral charge, they help allow protons to be next to each other. Okay, because remember, like charges repel and all the protons have the same charge, so naturally they want to repel. So neutrons help to prevent this, okay? And they also have weight, right? They weigh 1 AMU, they contribute to mass. Now the last one, electrons. Think about this idea of electricity. If you get hit by electricity, is that a good thing or a bad thing? If you get hit by electricity, is that a good thing or a bad thing? Yeah, that's a bad thing. So that's how I remember electrons are negative, right? I think this idea of getting hit by electricity is bad, right? So that's how I remember electrons are negative, or just by elimination, right? If you know protons are positive, if you know neutrons are neutral, then all that's left over are electrons to be our -1 charge. Yeah, this is -1 just like Efren said. Okay, now these ones are on the outside of our atom, right? They're circling around the outside of our atom. And for that reason, because they're the furthest ones out, they're the ones that are in charge of bonding with other atoms, right? Remember, H2O is made up of, water is made up of what 3 atoms bonded together? Water is made up of what 3 atoms bonded together? Think about the chemical formula for water, Efren. What's the chemical formula for water? What's another way? Yeah, H2O, right? So it's 2 hydrogens and oxygens that are holding hands to each other. And their hands that they're holding hands with are their electrons. So that's what you can think of it as. Smiley face if you understand that now, right? So electrons on the outside, negative, involved in bonding because they can hold hands with other atoms. Excellent. Now, they're very friendly, okay? Now, an important thing to notice we saw up there is that when we have equal protons and electrons, so equal positives and negatives, the charges balance out to what? Okay, when you have equal positives equals negatives, let's say +6 and -6, what does that equal? It balances out or cancels out to what? Yeah, exactly. So it cancels out to 0 charge, right? So when you have equal protons and electrons, it will balance out to 0 charge. Okay, and again, the number of protons, the atom's identity should always stay the same, because if you begin to change the number of protons, it's going to change the identity of your atom completely. Okay, looking good. All right, let's make sure we're beginning to understand this. Go ahead, work on this. Let's work together. Let's try to see if we remember these. So protons, neutrons, electrons. Go ahead, match these up on the whiteboard. Please use thin lines. Please use any color but red. Try to be neat with it. Awesome, appreciate it, looking good. Okay, we got charges down. I see the charges are down. Let's work on their roles now. Looking good. Let's make sure we understand their roles. Taylor and Efren, Jade and Jody and Dorian and Noah and Arrow on the board and Caleb and Amanda. Awesome participation, everyone. Ireland's on the board. All right, there's one that's missing. Which one is the smallest involved in bonding? Which one is involved in holding hands with other atoms? A role and a charge for protons. We got a role and a charge for neutrons. So it looks like, yeah, we're just missing electrons. There we go. All right, I'm going to go ahead, pause your tools here. Let me shrink these down. And let's go ahead and take a look at this. All right, get ready. This will be number 2 in your ticket as well. All right, so protons. Protons have a positive charge. We got that down. That was easy. Neutrons have a neutral charge. We got that down. And electrons have a negative charge, right? Because getting struck by electricity is a bad thing. So those ones we feel really good with. Love it. Now, in terms of their roles, so remember, protons are the identity of the atom. If you change the number of protons, it changed it from carbon to nitrogen to oxygen. It changed its identity. Smiley face if that makes sense. So protons are in charge of the identity of the atom. Excellent. Neutrons, seems like we understood this one pretty well. Neutrons prevent repelling in the nucleus, right? Those neutral neutrons are really good at allowing protons to hang out next to each other when they don't want to. They make what we call buffers, right? Think about if you have 2 friends that don't necessarily get along with each other, but when you're around, because they're both friends with you, they can hang out. You can hang out as a group. That's exactly what neutrons are. Neutrons are the person that helps to keep the relationships going between 2 people who don't necessarily want to be around each other. Thumbs up if that makes sense. So neutral neutrons are really good at being neutral. They're really good at helping balance, helping people buffer their electric personalities. Cool. Now, last but not least, electrons. I think I did forget to mention this. Electrons weigh 0 AMU. Remember, we saw in our demonstration that when we changed the number of electrons, it actually did not change the mass of the atom. So that is important to understand, that electrons are actually extremely tiny. And as I already mentioned, though, they are involved in bonding. All right, so they're very tiny and they are involved in bonding. All right, awesome. This is number 2 in your ticket. Give me a green check when you have this saved. I'm going to go ahead and actually give you 60 seconds because it's a little bit longer. Green checks all around. Go, go. Jasmine, Jess, Miguel, Misael, green check, taken care of. You can also take a picture if you guys want, but make sure you still give me a green check. Looking good. All right, let's go ahead and keep on going. All right, everyone. So the structure of the atom, right? We've already taken a look at this, but I do want to there should be 2 days of game day. You already get 10 days of game days within the quarter because there's one every unit. All right, so protons and neutrons are in the center of our atom. We already know that, but that center, I want to remind you, is called the nucleus. So when we talk about the nucleus contains both protons and neutrons. Smiley faces if you can see that here. Protons and neutrons, both of them, okay? Now, that being said, remember, protons and neutrons are the ones that have weight, right? They have mass. So that means that most of our mass is actually concentrated in the very center of the atom. The nucleus is the most massive part of the atom. Okay, so this is the most massive part, which, considering they're super tiny, is still not a lot of mass, but they are, if you were to zoom in, it would look like a planet versus outer space, right? So a planet versus a speck of dust in outer space, okay? So most of the atom, that being said, most of the atom is actually empty space, okay? So most of the atom, if you imagine a planet, is actually just the empty space around it. And there are tiny electrons that are flying around that nucleus, but those electrons are super, super tiny that they're almost non-existent. They have almost 0 mass. So again, that's like a speck of dust in outer space kind of rotating around this little planet, around this little nucleus, okay? So that being said, again, our atomic mass is made up from just the protons and neutrons together because they are the ones that actually have a lot of mass. Electrons we ignore because their mass is just so tiny, right? They're just that little speck of dust kind of floating around the outside of our nucleus here, okay? Moving around like this. And they're super, super tiny. So again, this is not to scale. Electrons compared to protons and neutrons are minuscule. They're very, very tiny. Okay, go ahead, give me a green check if you understand that. Green check if you understand that. Red X's if you're confused about that. Protons, neutrons, very massive. Electrons, very, very tiny. Excellent, excellent. All right, good. So that being said, I'm going to go ahead. I want to show you guys this really cool, useful website here. All right, can we see my screen? No, you don't have to remember any of them. I'm not making you memorize them. I don't even have them memorized. I have up to neon memorized, but at some point I had up to krypton memorized when I was a kid, but at some point I realized it was not useful to have them memorized because you have a periodic table as a resource. So whenever you have a chemistry exam, for example, in college, you always get a periodic table. All right, cool. So the website for this is ptable.com. All right, so there's that, or sorry, I'll write it as an actual URL, ptable.com. Here you go. Perfect. All right, so this is actually super cool. Let's go ahead and choose one of these elements to take a look at. So go ahead, tell me in the chat box, which element do you want to take a look at? We got a bunch of different options here. It's copper. All right, let's see here. All right, so yeah, I got a couple of votes for silver. So let's take a look at silver. Love it. Okay, so when you click on this, it's super cool. You get so much information on this. It's basically Wikipedia, but all in one place for all of the atoms. Yeah, so silver, you can actually see its symbol, which the symbol for silver is Ag from argentum. Argentum is the Latin for silver, or shiny and white. But there's a lot of great information about this. But what you can see here is when you scroll down, you can see really important information, right? Like its atomic number is 47. Remember, that tells us the number of protons. You can see kind of things that it looks like. You can see, let's see here. You can see lots of information about where it's used, right? So there's a ton of really great information with this. Yeah. I see, Dorian. Looking good. Yeah, so there's a ton of really great stuff with this. It tells you all about the history of it. But again, the reason that periodic tables are so helpful is because they have some really good information on them. So let's take a look at the square for Ag. Okay, so you can notice what, you see a number at the top. What's that number at the top? It actually shows up here. So go ahead, tell me, what number do you see at the top of silver? What number do you see at the top of silver? Top left. Yeah, you should see the number 47. So we're going to see number 47, again, is its atomic number or the number of protons. Remember, protons are in charge of its identity. So the number 47 will always be silver. If it was anything else, it would change its identity from silver. Smiley faces if that makes sense. So 47 is the atomic number, is the protons, is the identity, is silver. Okay, cool. And at the bottom, what number do you see at the bottom? Go ahead, tell me in the chat box. What number is that? Go ahead, just type it in. What do you see at the bottom? Should see a number. Yes, 107.87. Now that number, guys, is the average atomic mass of a silver atom. Okay, so this right here is going to be 107.87 AMUs. So that is the atomic mass of an atom. So let's go ahead and take a look at that a little bit more in depth. Okay, so you have your symbol. Okay, so the symbol tells you how we write it out when it's in a formula, for example. So for example, when we talk about sugar, okay, or glucose, we call it C6H12O6 instead of writing carbon 6, hydrogen 12, oxygen 6, because that would be way too much, right? Smiley faces if that makes sense. That would be way too much. Yep. Cool. All right. Awesome. And then we have its atomic number equal to the protons and its identity. And we also have the atomic mass, which is its number of protons and neutrons together. Cool. All right, let's take a look at this one. Stupid electrons, I'm sick of your negativity. Give me an LOL once you get it. Yes, because remember, electrons are negative. Electrons are negative. Cool. All right, the last thing that we need to talk about, which I'm going to kind of fly through because I realize right now that we're running a little bit behind. So we're going to talk about some different models of the atom. Okay, so here's the thing. We have to have different atomic models of the atom to understand it because no one has ever actually seen an atom. They're too tiny for us to really have good instruments to see exactly what they look like. Smiley faces if that makes sense. So that's why we use atomic models to kind of predict what we think the atom looks like. Okay, but we're not 100% sure. Okay, so in the beginning of this idea of trying to figure out what atoms look like, there was a model called the Thomson model, also known as the plum pudding or raisin bread model, that he thought it was a solid positive sphere that had little negative electrons kind of studded throughout it, like raisins, all right, or plums inside of it. Okay, so that is our plum pudding model for Thomson. Rutherford, on the other hand, Rutherford came in and he was the next scientist, and he thought that that solid positive mass was actually in the center as our nucleus, okay, and there were electrons surrounding it. So this one actually looks a little bit more familiar, right? Thumbs up if you can see how this one looks a little bit more standard. Now, sorry, I don't exactly talk about Dalton. That'll be on a different page, okay? Chadwick then discovered the neutron, and he actually incorporated that into Rutherford's model. So then he began to realize that the nucleus wasn't just, right, it wasn't just positive charge, but there were actually neutral charges there as well. So it was neutrons and protons that contribute to mass but don't change the charge of the atom. Then Bohr, all right, we can see Bohr. This one you should probably be most familiar with because this is the one we've been looking at throughout class. So Bohr thought that electrons travel in shells. So he took all the electrons and he organized them in little circles around the nucleus. And he said that the outermost shell was able to hold more electrons, and that was called the valence shell, and it was involved in bonding. So the outermost shell, the ones furthest out, were the ones that could hold hands with other atoms. Sorry, now I'm going through them a little bit quick. Here's a good one. So think like a proton and stay positive. I feel like this is the opposite of the last. All right. Now, the most recent model that we have is called the Schrödinger model, or it's called the electron cloud model. Okay? So the electron cloud model is our most recent model. And the reason for this is because electrons don't exactly have a spot that they always are. So what Schrödinger figured out was that when we can kind of predict kind of where an electron might be, but as soon as we try to measure where an electron is, that kind of changes the mechanics behind it, right? So this is what's called quantum mechanics, very, very tiny stuff. So as soon as you actually try to measure where an electron is, it changes the nature of that electron. Smiley faces if that kind of makes sense. So we can predict where it is, but we can't actually measure it without changing the changing its nature. Okay? So that being said, what happens here is that they took all of those predictions and we show that as kind of this fuzzy electron cloud of rapidly moving electrons where those electrons most likely have been. But it's impossible for us to know for sure because as soon as we measure it, we change it. Okay? So this is our most recent model. Now, that being said, we don't usually use that model in our class because that's kind of hard to see, right? It's kind of hard to be like, oh, there's a bunch of dots. I can do something with that. So that's why atomic models are so useful because different atomic models help us understand the different characteristics of the atom. Okay, so even though this is the most recent one, we tend to use Bohr's because Bohr's helps to break it down a little bit more in high school. Okay, and again, this is just because atoms are super tiny and we just have never seen them. I do want to mention, yes, as Mr. Alch was saying, we did have Dalton's, who was the original one, who just said that he thought that matter was broken down into discrete particles. All right, but we're talking about exactly what those particles look like as we've gone through history. Cool. All right, let's go ahead and match these up really quick. Okay, let's see if we can match up raisin bread. Who was that? Electrons, negative electrons in shells, the fuzzy path where electrons most likely have been. Go ahead and match those up. All right, let's go ahead and pause that. It's hard to see. All right, so yes, the raisin bread one, right, that is our Thomson one, plum pudding model. Bohr's is going to be where these negative electrons travel in shells. Rutherford's is going to be that first nucleus, okay? And then the electron cloud is our fuzzy path with rapidly moving electrons. Excellent job. This is number 3. You have 30 seconds to go ahead and get that in. And then I'm also going to go ahead and just put the last word in the chat box. All right, guys, go ahead, give me a green check. You can also take a picture and give me a green. Looking good. Okay, I'll come back to it in a moment, but again, we talked about atoms today. Mr. Alch is going to send you the quiz really quickly. All right, so please go ahead, send the 4A quiz. Again, all the answers are in the attendance ticket. And then here is your last word. The last word is pudding. Okay, so last word is pudding. I put that in the chat box already. And again, Mr. Alch is sending out those quizzes. All right, and I'm going to go back here to number 3. Thanks so much, everyone. Mr. Alch, please send it in the main room. In the main room, please. Cool. All right, bye, everyone.